In this lesson, we're going to look at more examples of using dimensional analysis. We're going to continue with examples of converting values among units. How many grams in 1.35 pounds? And the conversion between pounds and grams is given. This is something you'll be expected to know before we get to the exam, but right now it's given to you. First, we want to look for our starting units, which in this case is pounds because that's the value that's given in the question. Then we identify the units we want to finish with, which is grams, because it's asking how many grams. And we're given this relationship, 1 pound equals 454 grams. We begin the setup of the problem by starting with our 1.35 pounds because that's the value given in the problem, and we've established that pounds is our starting unit. Now we set up our parentheses, and we're going to put pound on the bottom and 454 grams on the top because we want pounds to cancel. Now we can solve the problem and get 613 grams. We want to ask ourselves, is the answer reasonable? When I think about 1 pound being 454 grams, then I know my value I started with was a little more than a pound, then I know my answer should be a little more than 454 grams. So my answer is reasonable. Now let's look at a problem where it's asking how many pounds is 652 grams. We still use the same conversion, 1 pound equals 454 grams, but we're going to use it in a slightly different way. So our starting units in this case is grams because we're given 652 grams in the problem. We're going to finish with pounds because the question is asking how many pounds. We start our setup with 652 grams because that's what was given in the problem. Then we set up our parentheses, and in this case we want grams on the bottom because grams is in the numerator on the starting, the 652 grams, and we want to cancel out grams, so we put it in the denominator. Note that the 454 always stays with the grams and the 1 stays with the pound because this relationship is true regardless of any other values, and we can invert these relationships as needed to make the units work out correctly. But when we invert the units, we also need to invert the values so that 1 stays with pound and 454 stays with grams. We can cancel out grams and solve our problem to get 1.44 pounds. As always, we ask, is the answer reasonable? So we have about 1.5 pounds, and we look at our value. 1 pound is 454 grams, and we see that 652 grams is roughly 1.5 pounds. Therefore, our answer is reasonable. Now we're going to look at an example where we again have multiple steps to solve the problem. First, we identify the starting and finish units. So we're going to start with miles because it gives us 0.75 miles, and it asks how many centimeters. So we're going to finish with centimeters. I start the setup with 0.75 miles. Put in my parentheses, and then I put the mile on the bottom. So 1 mile equals 5,280 feet. I can cancel out miles. Now the units in the numerator are feet. I'll put feet in the denominator and 12 inches in the numerator. Feet cancel out, and I'm left with units of inches. Now I do another step, and I've got inches in the numerator, so I need inches in the denominator, and I put 2.54 centimeters in the numerator. Units of inches cancel out, and at this point I'm left with units of centimeters, which is what's being asked for in the problem. I can now solve it on the calculator, and I get 1.2 times 10 to the 5th centimeters. In this problem, because 0.75 only has 2 digits, I need 2 significant figures in my answer. This looks to be a reasonable value because I have 0.75 miles, and a mile is a large distance. A centimeter is a very small distance. It's about the width of your pinky finger. So I need a lot of centimeters to equal 0.75 miles.